Okay, so in the previous video, we saw how to install the SwarmSight software for tracking antenna and proboscis of restrained insects, and it ended where we saved the file after analyzing it to a CSV file. So once you click this save button, it will save the file, the CSV file with all the tracking data next to the file, the video file that it analyzed. So here is the video file that we analyzed. And this is the same folder, and then right next to it you can see the CSV files. I've done this multiple times, and each time it does it, it adds a little bit more information like your username and a timestamp. This way you know who is doing it and exactly when it happened. If you go ahead and open up this file, you can see that it's a pretty simple CSV file. So the first row has all the columns, and then all the rows have all the data. So each row corresponds to one frame. The frames are labeled, and then you can see the data afterwards. So if this isn't, it's not very fun to look at this in WordPad, so we'll go ahead and open this up in Excel. So go ahead and do. Okay, so once you have the CSV file opened up in Excel, you should see something like this. Here I've expanded the columns and the column names, so you can see everything fairly well. So what I'll do is I'll go over the columns and what they mean one by one, and I'll give you an idea of what they all do. So this first column is just a custom column that the user specifies. So you should be able to notice, and you should be able to set the value to whatever you want. So in the software, here's the custom column, so that becomes the name of the column. And value is none, that becomes not. So you can put anything in there. Usually people put in things like the conditions, such as a control or the animal or an individual that they're using, or maybe the person who's running software or something like that. Anything that might be useful for your experiment. The next one is the frame. This just tells you which frame the measurements were made. So this is the first frame, this is the 30th frame. We know that this video is 30 frames per second, so this means that this data right here, this entire row, represents the measurements that happen at 1 second after the start of the video. Then we have the next one is the treatment sensor. So this is the value of this little widget here that measures the brightness at the point right in the center over here. We can go ahead and visualize that real quick to give you an idea what that looks like. So I'll make this plotted as a line, and you can see how what's going on in here. So notice how there was if you saw the previous video, you noticed that there was a shadow of a person moving over here, and you can see that there's a big dip here. So this is just simply responding to a drop in brightness during that time. Then you see there was, I remember, and then a few seconds later, after the person was moving, you saw this red sort of a LED light diffusely coming out there. The reason for that is because there's an LED, but it's positioned slightly to the side of the screen, so you can't actually see directly, which is why the brightness only goes up a little bit over here. If the LED was positioned bright in the video and this little widget was on top of it, usually the brightness goes to the maximum value, which is 100, and then it's much easier to tell when exactly the treatment is being administered. So here it's much lower, but it starts around 16 seconds and ends around 20. So we know that this is about 4 seconds of odor delivery taking place. The odor is coming from basically from the top, this top part of the video. It's somewhere over here, and it's blowing this way towards the insect. And then once you see that once the odor is delivered, the LED stops shining, it sort of goes back to normal, and I'm not sure exactly what's happening here. But anyways, it's really important to have the LED visible in the video so that you can accurately determine when the treatment stopped and ended. The next two columns is the PER, X and Y positions. So the PER just stands for Proboscis Extension Reflex. In here, in this video, the insect did not extend its proboscis, so basically it just measured this point, which is at the tip, or at the very edge of the mandibles. If the proboscis had moved, say further, you'd see that the values here would have changed. Now you can see that they're all the same. The next two is the sector measurements. So note how the left and the right sector. So this is actually showing us this part right here. So this is a screen that was visible at the end of the video. So let me go back to the very last frame. Okay. So here it is. We see in the last frame it said treatment sensors 56. Okay, this is the one. So it's this PER when it says 312 of x. So all these coordinates of x and y are measured from the top left corner of the video, and it's measured in video pixels. So we see 312, so that means that from here to this point, there's 312 pixels, and then 171, it just means 171 pixels from the top over here. So it's basically staying in that position the whole time. The next two measurements is the left and right sector. So to get sometimes the video is too noisy, or there's like shadows and other things going on, it's just not accurate. So often in that case you can use these the sector measures. So what it does is the software takes this sort of a circular region around the head and divides it on each side into 5 dominant sectors. And so these sectors are basically 36 degrees wide each. And what they do is this measure will tell you these yellow points, which is the antenna that the software is likely detecting, or believes or thinks is are the antenna. And it gives you the sector in which there's the most, that has the most of these points. So you can see that it's showing sector 3. So most of these yellow points are in this sort of area region over here. So that's why it's showing 3. If it was over here somewhere, you would see 1, and then there's 2, 3, 4, and 5, and the same thing on the other side. Here you see 4, so it's not exactly in the middle because it's slightly lower, so that would be the 4th sector that's shown. So these are the values that you see in these columns. Okay, moving on to the next two. So left flagellum tip, X and Y. Again, these reflect the antenna tips. So these bubbles that you see over here and the tips, this is where these values are pointing to. So this X1 is the left side, so it says it's 208 pixels from this head, from the left side, and 233 from the top. The next two columns is for the right side, so it's now the X position of this one is about 406 pixels, and it's 278 from the top over here. So this is how you can localize where the tips of the antenna were in the video. Moving on to the next one, so this is the flagellum base, X and Y. So this actually, for the left side, it's actually pointing to this side here. It's not marked as a bubble, but that's where it's pointing at. And so you can see that it's pointing to about 263 pixels from the left side and 236 from the top. So that's right over here. Similarly, on the right side, it's pointing to this point over here. So that pretty much gives you the information to find where the tips were located. There's additional columns that would give you an idea, or gives you all the information needed to compute things like angles and like relative positions and distances, for example. In order to do that, you have to have this other information. So that's what these other columns are for. So this rotation angle is gives you the rotation angle of the widget. So you might notice how in the beginning, if you watched the previous video, you'll have seen that I had to rotate this a little bit because the head is pointing slightly to the left. So this says it was rotated 3 degrees to the left. If it was positive, it would be rotated in a clockwise direction to the right over here. The next two columns for the antenna sensor width and height. Basically, this just tells you how wide this rectangular region is and how tall it is. Because it's rectangular, both of these values are the same. So the 260 just means that this is 260 video pixels across. Now these next two columns is the antenna sensor offset. So again, this is 185. So that means this right here. This offset tells you how far away is this leftmost edge of this widget is from this top left corner of the video. And it just shows that it's 185 pixels from the left side of the video and 106 pixels from the top. So if you know how far away the widget is, and you know the sensor width, you can get its center. So the center here, which is this yellow point, is directly halfway. Basically, this is a halfway point between the width and the height. So this is at the midpoint of the width and the midpoint of the height. And so from that, you can know exactly where the bee's head center was. And then from that, you can, and because you know the rotation angles, you can then compute the angle. It's possible to compute the angle of the antenna to the sort of the front of the head, regardless of which way the bee head is being rotated. So as long as you correctly position the widget and rotate it and scale it, the software you'll be able to compute the angles towards like an odor source correctly, or relative to the head at least correctly. These last two columns is the antenna sensor scale. Remember, this widget was also scaled. The units are arbitrary. You don't know why you would need to use this, but perhaps it might be useful later. So that finishes up the columns, and in the next video I will talk about how you can use these columns and the data that's in here to get things like to plot the values of the antenna movements, to compute the angles, and then compute sort of a density maps for those angles to see if there's some sort of response to the odors that the insects are showing. Okay, thanks.